Hi, I'm Ty Schmidt, Executive Director for the Dell Modular Infrastructure team here in Longmont, Colorado to show you some exciting new product solutions that are coming out of our group.
I'm Mark Bailey, the Principal Architect for the Modular team. And we're going to start by showing you guys our latest installation that's standing behind us.
So what you're looking at here, this is a approximately 2.5 megawatt capable site. Understand that we've got various modules that perform a certain function. So we have a power module, we have IT modules, we have cooling modules, mixing modules, control modules. There's a number of modules. They all have their function. The intent or the goal was to right size these modules to do what they needed to do at the most optimized cost. The topology of these modules, you have an IT module, an evap cooling module, an air handler module, and a mixing module. Depending on what condition, how hot or cold it is, dictates what mode of operation this module is in. And so, for instance, today we are actually going between a day cold enough to warrant a mixed mode to a warm enough situation where evaporative cooling is turned on and we're actually cooling in an evaporative mode.
This has three basic modes of operation. You're either operating in a mixing mode, where in which you're taking the return hot air from the IT and remixing it with outside air to basically get the ambient temperature to the inlet to the servers that we wanted. The second mode is the traditional outside air mode, where literally you're pulling in outside air that is filtered across the servers that basically does not require anything other than an air mover to facilitate the cooling. The third then is when it becomes too hot. And what this customer selected and what we've now deployed for them is a direct evaporative type of cooling, where in which we ultimately are using a type of swamp cooler technology to remove energy from the air and thereby reduce the inlet temperature from the outside to the servers.
All right, so I'd like to walk you through one of our IT modules and point out some of the critical elements to the design. These particular racks are 54U. They are standard 19-inch racks, but they are designed specifically to integrate and ship with these modules.
So these racks of equipment are outfitted with Dell engineered gear. Gear that was engineered by the same engineering team that architected and engineered the module. So what we have is a fully vertical solution all the way from the actual IT itself to the modular data center. What that allows us to do is remove fans from the systems themselves. So in each of these racks, there are no fans in the servers. The only fans that are present are in any networking gear that would require them. What that allows us to do is that allows us to remove that burden from each server and apply it to more IT in our module. So effectively what we're doing is we're making our modules more power dense and removing elements that decrease efficiency. So by not having fans at the small scale, what we're doing then is utilizing fans at the large scale or in our air handler. So we're standing in the hot aisle of the legacy module that holds a vast array of different types of IT and compute gear. What this customer wanted was they wanted to have a specific type of power at each rack and a specific power density. In this case, 400 volts taken directly, 400 volts three-phase taken directly to each rack and distributed at 235 directly into the gear. The custom rack that Dell has integrated into our IT modules does accommodate up to 4 traditional 56mm wide PDUs. It can accept various vendors' types of PDUs, and they all mount with the traditional and standard type of mounting features.
So I wanted to specifically look at a little bit more closely the power module for this particular solution. So the concept of our power module is really it's a right-sized element based on the geography, based on the modes of cooling, the level of availability, the level of power, the level of ride-through time. All those factor into the design and requirements for the power module. This particular power module basically does the major transformation and to generator neutral. It also has the air handler, UPS and batteries, and switchboard, main switchboards as part of the critical elements for this module itself.
What this module does is it takes facility power in, which you can see coming in through the foundation, and then what it does is it distributes the power to the various IT loads as well as to the air handler itself.